Unsloth Studio promises local AI fine-tuning without code. Turn documents into training data. Export a model you can run yourself. Unsloth Studio puts data, training, charts, checkpoints, export, and a local API inside one interface. Normally, each step means another tool and another handoff. It looks like the local AI dream. But what complexity has actually disappeared, and what is merely better organized? The headline is strong: open source, local, and available on Windows, Linux, WSL, and macOS. Here is the first reveal. Studio is not one new training engine. It is 3 connected layers, with a clean interface sitting above a familiar technical stack. The top layer lets you choose a model, prepare data, train, read progress, and export. Below it, Unsloth Core optimizes supported training paths to use less time and memory. Underneath are PyTorch, MLX, Hugging Face, and Llama CPP. Studio makes those pieces feel like one system, so state can move forward instead of being rebuilt at every step. Now test the promise: teach a local model to answer from support documents. Start with a model in Dataset. Studio can use Hugging Face sources, local checkpoints, or uploaded data. The method changes the cost. LoRa trains a small add-on. Full training changes the entire model. For many local projects, the smaller adapter is the practical starting point. Studio suggests settings and estimates memory. Advanced controls remain when the defaults do not fit. Press train and progress, memory, speed, logs, and loss move together on one screen. You no longer have to match a notebook cell with a separate terminal log. Checkpoints appear on the same run. Stop, resume, compare saved moments, and choose one to export. Here the no-code story stops. Falling loss does not prove the model learned the right behavior. Only a separate evaluation on realistic questions can tell you that. Next comes efficiency, about twice the speed and up to 70% less memory for supported recipes. Those are framework claims, not a guarantee for every run. But the mechanism is concrete. Optimized operations take shorter paths. QLoRa keeps the base compressed and trains only a small adapter. That combination is why a useful experiment can fit where full training cannot. Short examples can be packed together instead of processing empty space. The savings do not make memory unlimited. Now the demo meets your machine. Runs locally is not one promise. Each task needs different resources. Preparing documents is cheap. Updating billions of model weights is not. NVIDIA remains the established path. GPU memory holds the model and temporary training state. AMD training spans Windows, WSL, and Linux. The GPU generation and software paths still matter. Apple Silicon can train through MLX and run GGUF through Metal. That is current, not roadmap. CPU handles chat and data preparation. Vulkan accelerates some GGUF models. Neither makes every laptop a trainer. The ceiling returns to model size, compression, input length, and how much you train. Change anyone, and the same machine may move from comfortable to impossible. The project spans language, vision, audio, embeddings, and image generation. Even text spans adapters, full training, continued pre-training, preference tuning, and reinforcement learning. But breadth is not universality. An image model needs different data and code than our support assistant. Check the whole route. Can Studio load, train, and export that model on your hardware? A working chat demo proves only the first part of that route. Now rewind to the most important input. Data recipes ingest PDFs, tables, JSON, spreadsheets, and documents. The app extracts text, maps fields, generates examples, previews, filters, and saves a dataset. That turns an awkward collection of source files into something training code can consume. This is real workflow compression. Yet the output must still match the model's roles and template. No interface rescues bad examples. Repetition, wrong answers, missing cases, and leaked tests still damage the model. Data recipes reduces preparation work. It does not certify the result. Now the promise pays off. Keep the adapter, merge it, save locally, or send supported files to Hugging Face. Studio exports several GGUF sizes. Smaller versions need less memory, with a quality trade-off. Run GGUF through Llama, CPP, or expose an OpenAI-compatible local API. Documents have become a usable endpoint without manually rebuilding the project inside a separate serving stack. That end-to-end moment is Studio's strongest argument. One reality check remains: It is beta, and fast-moving beta software makes today's exact compatibility more important than launch day impressions. Compatibility is a matrix. A model may chat yet lack training, export, or support on your hardware. Confirmed issues include hardware selection, routing, stalled output, and platform-specific installation. They are scoped, not universal. Releases move quickly too. Several launch problems are fixed, so old reviews can mislead in both directions. The durable limit sits below Studio. Backends still decide which devices, formats, and models are possible. What survived the hype? Our data, settings, training, checkpoints, export, and local tests share one environment. The model did not become simple, the journey became continuous. That removes handoffs while keeping data quality, hardware limits, evaluation, and deployment decisions visible. The verdict is a qualified yes. Studio makes local fine-tuning substantially easier to operate. The ideal user wants fewer notebooks but still inspects data, settings, logs, and final behavior. The magic button is hype. The connected local workbench underneath is what actually matters.